So hello guys, in this video we are talking about Spark, Apache Spark execution tuning. So this is the content. Then let's start about. So first it is what is an executor. Executor is is JVM process launcher on worker node in Spark cluster. It is responsible for running tasks assigned by driver, storing data in memory, cache and persistence, writing shuffle output to local disk. There is a like a Spark cluster. In that we have driver, worker node 1, no, worker node 2. In worker node we have executors, executor 1. In that, in executor we have task 1, task 2 up to task n per one per core. Key rule is like there is only one executor core is equal to one task running in parallel. So executor with 5 core runs 5 tasks simultaneously. So node versus executor versus task. Node, like, what is an analogy? Node means like physical and virtual machines. Means like office building floor. Executor means JVM process on node, means team on the floor, on that floor. And core is thread inside the executor, means individual worker. And task means a unit of work on one partition, one assignment for one worker. Then the three sizing strategies. Given cluster of 5 nodes in 12 cores and 48 GB RAM. First subtract 1 core and 1 GB RAM per node for OS, Hadoop and diamonds. Enable per node is like usable per node is 11 core and 47 GB RAM. So there are 3 strategies: fat executor, thin executor and optimal executor. Let's talk about for each. Fat executor, per node each per node one executor in having 11 core and 47 GB RAM. Cluster have 5 executors, so 5 into 5 cores, 11 core, 5 executor, 11 core and 47 GB RAM. So spark submit command should be spark dash submit. In that executor 5, executor core 11, executor memory 47. Why fat executors seem attractive? Because all 11 cores should share one large memory pool, useful for operations require large broadcast tables. Fewer executor JVM process, lower per process overhead. The real problem is like HDFS throughput degradation, means HDFS client on each executor use multiple threads to read write data. With 11 concurrent threads per executor, HDFS IO concentration become bottleneck. The community recommended or database guidance is 3 to 5 cores per executor for optimal HDFS throughput. Here we are using 11 core. We have to use 3 to 5 cores. Also, like limitation like garbage collection pressure at scale, then fault tolerance risk, reduce underutilization. Summary is like in fact executor task level parallelism and data locality is high or good, but the poor performance it is in garbage performance, HDFS throughput, fault tolerance means poor, expensive to restart, resource efficiency. बेसिकली फॅक्ट एक्झिक्युटिव्हमध्ये क्लस्टर मोठा असल्यामुळं जर डेटा लॉस झाला तर ते रिकवर करण्यासाठी खूप वेळ लागतो, त्यामुळे ते एक्सपेन्सिव्ह असतं. नेक्स्ट इज थिन एक्झिक्युटर, मीन्स कमी कोअरचे म्हणजे एक्झिक्युटर वापरायचे, पण जास्त एक्झिक्युटर वापरायचे कमी साईजचे. लेट्स टॉक अबाउट दिस. पर नोड 11 executor, 1 core 4 GB RAM. Clusters are 55 executors, 1 core 4 GB RAM. So Spark submit is num executor 55, executor core 1, executor memory 4 GB. Why thin executor seems attractive? Because more executor level parallelism, small unit of failure. So if one executor going to down, it will lose only one task. The real world problem is like no multi-threading benefits, because with one core there is no parallelism within executor. Then high network traffic and shuffle cost. With 55 core executor each holding tiny memory, shuffle data is fragmented across many executors. This increases network traffic during shuffle read phases. There are also JVM overhead into 55. Each executor is separated JVM process. 55 JVM is equal to 55 set of JVM setup overhead. 55 separate replication cycle to manage, and 55 heartbeat connections to the driver. Next is reduced data locality. Summary is like thin executor we can it is good for level executor level parallelism and fault tolerance, but is not used for memory sharing, bad for network, high network traffic, poor local data locality, and high JVM process overhead. The rule for optimal executor size is like there are four rules. First it is reserve one second. Okay. First rule is reserve one core plus 1 GB RAM. First reserve one core and 1 GB per node for OS, Hadoop and YARN. Then second rule is reserve resources for YARN application, means AM. One executor worth it for resources not needed for fat executive approach. Typically 1 core and 1 GB RAM at cluster level. Rule number 3 is use 3 to 5 cores per executor. Balance database throughput, garbage collection pressure and parallelism. 5 core is most common sweet spot. Fourth rule is executed memory. You specify exclude overhead memory, means like memory overhead is equal to maximum 384 MB or 10% of executed memory. So subtract overhead before specifying dash executor dash memory. That is executed memory is equal to allocated memory per executor minus overhead memory. Let's talk about why data size does not directly drive executor sizing. This is a common misconception. Executor sizing is about memory per core, not total data size. The correct mental model one core is processes one partition at a time. So you need memory per core greater than equal to number of one partition. Default partition size is 128 MB. In example 1, memory per core is equal to 4 GB. You have 332 into heart room per partition, means many of rooms. Data size matter for number of partition and parallelism planning, not raw executor memory size. How Spark partition 10 GB file, default is 128 MB block size. So 10 GB means 10 into 124 MB is equal to 240 MB. So 10 GB to 10,240 divided by 180 equal to 80 partitions. So with 10 executor into 5 cores is equal to 50 parallel tasks. So 80 partition divided by 50 parallel slot is equal to near about 2 wave of processing. This is fine. No need to resize executor for data value. If partition are too large, causing out of memory issue, so you tune spark.config.set in bracket spark.sql.file.max partition bytes, 64 MB, or you can repartition to 200. repartition in bracket 200. Interview question will start. What is executor in Spark and what does executor core mean? Executor is a JVM process on worker node that run tasks and store cache data. Executor dash cores define how many tasks can run in parallel with single executor. If you set dash dash executor dash core 5, that executor run 5 tasks simultaneously, each one of partition. Next question is, why do we subtract one core and 1 GB per node before sizing executor? Answer is, every node run of operating system processes and Hadoop yarn domains, means node manager, data node, etc., that need CPU and memory to function. If Spark claim all resources, those daemons get starves or causing node instability, yarn heartbeat failure, and potential executor losses. It is standard practice to leave at least one core and 1 GB per node. What is next is, what is yarn application master AM, and why does it need resources? The yarn AM is process responsible for negotiating resources with resource manager, means yarn, and managing Spark driver lifecycle on yarn. It runs on one of the node and needs a small portion of cluster resources, typically 1 core plus 1 GB RAM. If you don't account for it, yarn may fail to launch application master, means AM, causing the job to not start at all. Next question is like, how do you decide executor size? How do you decide executor size when given cluster space? Walk me through the process. There are 4 steps. One, subtract 1 core plus 1 GB per node for OS. Then subtract 1 core plus 1 GB at cluster level for yarn AM. Decide core per executor, means target is 4 to 5, and divide total core to get executor count. Fourth, divide total remaining memory by executor count, then subtract overhead memory, that is 384 MB or 10% of raw memory to get executor memory. For 5 node cluster with 12 cores and 48 GB each, the result is 10 executors, 5 cores, 20 GB RAM. What is 3-5 core recommendation important for HDFS based cluster? Each executor core swam HDFS client thread for reading or writing data. HDFS perform best with around 3 to 5 current client thread per executor. Beyond 5 threads, HDFS IO become contended, means multiple threads compute for the same HDFS block, disk bandwidth, and network slot, actually reducing throughput. This is the primary reason for FAT executor 11 underperform in HDFS environment. Why is dash dash executor dash memory not the same as memory yarn memory yarn allocates? Why is executor memory not the same as memory yarn allocates? Executor memory defined only on heap JVM memory. Yarn actually allocate executor memory plus overhead memory overhead. The overhead is 384 MB or 10% of executor is used for off JVM process, Python worker process in Python, NAT network buffer, and OS level memory. If you set dash dash memory executor memory 20G, yarn actually reserve 22 GB for executor container. On Databricks, you don't use Spark Summit with dash dash num executor. How does executor sizing work there? Databricks use cluster configuration in UI or via job API, that is name workers and node type ID. The key difference in yarn, you In yarn mode, you size executor manually via Spark Submit flag. In database, you choose mode type. The example standard DS3 V2, like that. 4 core, 40 GB, and Databricks auto configure one executor per worker node with executor or memory preset to the node space, meaning minus Databricks work runtime override. You can override with spark.executor.core and spark.executor memory in the cluster Spark configuration section. For auto-scaling a cluster, Databricks dynamically add or remove worker. If here you focus on ensuring partition count cells with worker count. Target 2 to 4 partition per node. Then 8th question is job run define on your cluster, but after adding more data, means 3x volume, you start hitting out of memory error. The cluster space haven't changed. How do you approach this? Again, job run fine on the cluster, but adding more data, start hitting out of memory error. So what we will do? So more data usually means more large partition. Out of memory is typically not a sizing issue, but partition skew or partition size issue. First, I will check partition size in Spark UI. In Spark UI, I will go stage, then task. If some task process 10x data more data than other, you have skew data. Then I will check shuffle partition. Spark.sql.shuffle.partition default to 200. With 3x data, you may need 400 to 600. Then I will check broadcast join. If table grow beyond auto broadcast join threshold, means more than 10 GB is a default, Spark stop broadcasting it and fall back to short merge join, causing sudden large execution memory spikes. Fix is like increase shuffle partition, salting for skew, adjust broadcast threshold, not necessarily more executor memory. You are running Spark job on 10 node cluster with 8 core and 32 GB node. Size the optimal executor and justify each decision. Step 1, per node usable. Core is 8 minus core is 8 and memory is 22 GB. So for node for OS we have to give 1 GB and 1 core. So 8 minus 1 is 7 and 32 minus 1 is 31 GB. Step 2, cluster total. 7 into 10 is equal to 70 core and 31 into 10 is equal to 310 GB memory. Third step is subtract for yarn AM. We have to subtract 1 core and 1 GB RAM, 1 GB memory. So 70 minus 1, 69 core we have, and 310 minus 1, 309 GB memory we have. Step 4, 5 core per executor. Spark skip 5 to HDFS plus GB garbage collection balance, means executor is equal to 69 divided by 5 is equal to 33 executor, and memory per executor is 309 GB our memory. So 309 GB divided by 30 is equal to 23.8 GB, near about 23 GB. We are taking 23 GB memory per executor. Then subtract overhead, means overhead is equal to max 384 MB or 10% of memory. So here memory we have 23. So overhead memory is 2.3 GB, and for Spark I have extra overhead buffer, means Python worker dumped to 3 GB. So executor memory equal to 23 minus 3 GB is equal to 20 GB executor memory. So final is number of executor is 30, executor core is 5 and executor memory is 20 GB. Spark.executor.memory overhead is equal to 3 GB explicitly for PySpark. So real questions. So scenario 1, ETL job failure with container killed by Yan. You submit PySpark job on 10 node Yarn cluster, 11, 12 core and 48 GB each. You used a fat executor configuration, 1 executor per node and 11 core, 40 GB RAM. 2 hours in Yarn, 2 hours in Yarn kill executor container. Root causes you set Spark memory 47 GB. Yarn cluster container size is 47 plus overhead is equal to 47 plus 44.7 is equal to 52 GB. Yarn container size. No total RAM is 48 GB. Yarn kill container because it exceeded physical memory. Totally, additionally, Spark Python worker processes consume additional overhead memory, means not accurate for. Fix we can do like correct sizing, leaving 1 GB for OS and accounting for overhead. Use 47 GB per node. Overhead is 384 GB, comma 10% of memory, used memory. So here we have overhead memory is we are taking 2 GB because executive memory is 18 GB. So 10% 1.8 GB. So 1.8 GB is near about 2 GB. So total executive memory is 40 GB. That plus overhead is equal to 4 GB. Yarn allocated 44 GB. Fit into 47. That's it about this topic. We will see in next lecture, next topic.